hi everyone. I'm here for the PDN to RDF group, RDF knowledge graph construction, and for also some gender representation. So our overall goal with this project was to enhance the interoperability of PDN within the linked data ecosystem of SIB. So that includes like UniProt, RIA, Swiss Lipids, XPASI, other things. And the idea was instead of the user having to go and query each API or database independently, having one entry point to all of these things at once. And we wanted to do this with RDF because most of SIB resources are already in RDF format, and two, because it would allow for like data integration and interoperability because we have this standardized graph-based format. And it makes it much easier to integrate all of these resources and databases that are very different and that also evolve over time. So the workflow that we came up with and we ended up developing the last couple of days is in two parts. So an offline pipeline and an online pipeline. The offline pipeline starts with ENA, European Nucleotide Archive. We started with this because it's part of PDN and David in our group is part of ENA, so it's much easier for us. And we took the top 100 hits of the priority pathogens that PDN defined. From there, we developed a schema and built an RDF graph. The RDF graph was also augmented with a tool-binded LLM that queried UniProt. I think one of the other groups did kind of the same thing. You take either the taxon ID, you get the name, and from the name you can get the pathogen class. So either it's a virus, a bacteria, whatever. With this RDF, we can build a knowledge graph that connects to other SIB resources. And then we built a bunch of examples. And those examples are natural language questions associated with SPARQL queries that answer those natural language questions. This is our offline pipeline, and this is what we originally set up to do. But then what we added was having an LLM, and we exposed this LLM to all of these, well, I say all, it's like two examples that we built, to these examples because we want to have an online pipeline that we very innovatively called PDN GPT. And that logo is generated by ChatGPT as well. So with the online pipeline, what happens is you have a user. This user asks a natural language question, right? Could be whatever. We'll show you an example later. This natural language question goes into this LLM. The LLM will generate a SPARQL query inspired by the examples that we built. The SPARQL query will then be applied to the knowledge graph that we built in the offline pipeline, and then we'll have results from that query. The LLM will then summarize the results and send the summary back to the user. So the user of the online pipeline will get at the end both the SPARQL query and the summary of that query. And so you could see quite quickly how that PDN to RDF knowledge graph build-in was useful because on the left, we have the knowledge graph of only monkeypox data from only Japan, from ENA. And then on the right is for the 100 first hits of the 198 PDN priority pathogens. So it makes it much smaller, much scalable and usable. And so when we started this Codeathon, our objectives were to build these example queries and use cases to expose the LLM to them. This is something that we've managed to achieve. Build that schema profile that informs the choice of the relevant SIB resources and PDN resources that would be used. This is also something that we've managed to do. And then the third thing that we originally planned to do was, and we managed to do as well, is that RDF transformer thingy. This is the offline pipeline, so the first part of the workflow. And then the bonus thing that we managed to do was also the online pipeline, which was cool. And now it's demo time, and you actually see the online pipeline, which is really what matters, because the offline pipeline, as a user, you probably will never see it. I'll let Panayoti show you how to use it.
Okay, so we will be brave enough to do the demo live. Let's see how it goes. Okay, so here is the interface for this PDN GPT that we built, also the logo. And we pose this question, which is provide an extensive list of the pathogens that have been sequenced in China. So what it does now, as I'm speaking, is that it translates this question into a SPARQL query. I hope you are not running a lot of jobs in GPT-5 because that's a model that we chose. So it generates the SPARQL query. At the same time, to save some time for the demo, I will pose the same question to actual ChatGPT. And that's also down. We managed to break. Oh, yeah, now it's syncing. So it's kind of a complicated question in a sense that now it searches for the findings in some journals, the papers, everything. And you see, you have the results. But in the example that we did is that you have to search to specific databases. And essentially what we do is a more informed search. So this is the results from ChatGPT. Let's see if that didn't run, but I have a backup. If I was very quick in my typing, you wouldn't guess, but so this is the SPARQL query that it generates. And then we pose this query to the database, and then we retrieve the results and we summarize the results. So in a sense, these are two answers for the same question, but this one is a more informed answer because it is generated from ENA. So in these results, we have 22 pathogens. You see the categories. You see that they're also grouped by category, and it's a kind of short answer. I mean, we're not claiming that it's better than the ChatGPT one, but it's more specific to the task and more informed, if you want, answer. And the nice thing is that we can pose whatever question we want, and the SPARQL query, it is adapted to the question. So if I change China to another country, or if I say give me the top K, or if I say something else, this is mapped to a query, and then the results are summarized, and it's kind of unified way to show the results. So that's the demo. All of it is open source. I mean, we post all the code in the repo.
So yeah, this is kind of in line with other work that we've been doing. It's something called Xfuzzy GPT, which has the other resources that you can query in the same way. But what we'd like to do is incorporate the additional PDN data sources and potentially from other BRCs as well to improve the coverage of the tool. We'd like to also optimize the process to limit data duplication and not end up with this huge graph. Also, probably changing a bit the schema profile to be aligned with the new data that's added. The most important thing I'd say is curate additional examples to be exposed to the LLM to have it learn a bunch of different new cases, and also turn this entire workflow into an MCP server for improved utility. And yes, Binayoti said, we try to write documentation on the Git. So if you want to do it to your resource, or if you want to change it, just use it, just test it, feel free to do so.